Hello everyone. In my last lecture we have discussed about the heat. In that lecture we have discussed about the difference between the heat and temperature and thermometer. Today we are going to learn about the calorimeter. Now what is a calorimeter? That is the first question which arises in our mind. Calorimeter is an instrument which is used to measure the heat absorbed or evolved in the process. Now what kind of the process it will be? It can be any physical process, it can be any chemical process. So during the process, whatever heat is evolved or whatever heat is absorbed, that can be measured with the help of calorimeter. Let's understand the first structure of the calorimeter. Calorimeter has different parts. The first part is the inner vessel. This inner vessel of the calorimeter is made up of copper. Why only copper? Why not the other material? Copper is the best conductor. Hence we are using the copper as a material. So the inner vessel is made up of copper, which contain a stirrer, which is also made up of copper. Stirrer is the, you can say, spatula, which can be used to distribute the temperature inside the water. This inner vessel is surrounded by the outer vessel, which is made up of wood. Wood is the insulator, so it will not allow the outer heat to get inside or to inner heat to go outside. Now the in between part of this two vessel is filled with the insulating material, and here we are properly providing the isolation from the surrounding, so that inner heat will not move out and outer heat will not get inside. The top will be again closed by the wooden lid, as wood is the best insulator. Inside this inner vessel we are putting a thermometer. We are keeping inside thermometer. Now how heat can be measured? Suppose this inner vessel is filled with the water which is at room temperature. So it is but obvious that the copper vessel will also acquire the temperature of the water. So I can say that both inner vessel as well as the water inside are at room temperature. So I am saying that the temperature of the water is denoted by TW, whereas temperature of the copper vessel is denoted by TC. Mass of the water will be denoted by MC, whereas mass of the copper vessel is denoted by MC, whereas mass of the water is denoted by MW. In the previous lecture we have learned about the specific heat. I am just recalling it. Specific heat is the amount of energy required to raise the temperature of 1 gram of the substance by 1 degree. Every material has a different specific heat. So the specific heat of the calorimeter, that is your copper vessel, is denoted by Cc, and the specific heat of the water is denoted by Cw. Now I am having the water inside which is at room temperature. I am having one object. Consider a metallic sphere, and this metallic sphere at high temperature, whose temperature is, say, TO. It is the temperature of the metallic object. I am here saying that temperature of the metallic object is greater than that of the temperature of the calorimeter, or you can say temperature of the water. So this object is at high temperature. When this object is at high temperature, Let's talk about its mass also. The mass of this object is MO and specific heat of this object is CO. When I am putting this metallic sphere which is at high temperature, when I am putting this metallic sphere inside the water, you all are aware the heat exchange will take place. Heat will transfer from the hotter object to the colder object. The object which is at high temperature to the object which is at low temperature. So obviously this object will lose the energy, and that energy or that heat can be gained by the water. Water is in contact with the copper vessel, so obviously the same amount of energy, I can say, get absorbed by the copper vessel itself. You all are aware of the energy conservation law. The energy can neither be created nor destroyed. It can transfer from one body to another body. Now total universe energy of the universe will remain constant. Here what exactly happens when you are putting the object inside the copper vessel? This object will lose the temperature, it will lose the heat, and that heat will be gained by the water as well as your calorimeter. So if I want to write the entire story in the mathematical form, then I can say that heat of the object is equal to sum of the heat of the calorimeter, that is your copper vessel, plus heat of the water. So here I can say that since we have provided a proper insulation and the isolation, the heat cannot goes out. That heat, total heat, will be absorbed by the water, and the calorimeter is equivalent to the heat lost by the object. Now you all are aware that heat is nothing but mass into specific heat into difference in temperature. This difference in temperature is nothing but the final temperature of the object and the initial temperature of the object. It is a difference between the final and the initial, where in this case object is losing the temperature. If the object is losing the temperature, I can say that the final temperature is lesser than the initial temperature. So the product of this can be negative, and this negative sign shows that heat is given out. Whereas heat absorbed by the copper vessel, which is your calorimeter, can be written as MC, which is mass of the calorimeter, Cc, which is specific heat of the calorimeter, multiply by again delta Tc. Delta Tc. Here the temperature of the water initially was low, but after absorbing the heat which is given out by the object, the temperature of the water will rise. So the temperature difference, that will be positive, and positive difference shows that the temperature, that heat is absorbed, not evolved. Similarly, I can say that the heat of the water, here it is mW multiplied by Cw multiplied by delta Tw. Initial temperature of the water was lesser, final temperature of the water is higher, so again the difference is positive, and here we can say that the heat is absorbed, not evolved.